And thanks everybody for joining us here again today. Let's get started. Again, my name is Chris Bunz. I'm currently a senior and the lead developer advocate for serverless technologies here at AWS. Joined AWS a little over 5 years ago and have been here across a couple of different roles. But today my job primarily focuses on working with our customers that are using serverless technologies and building serverless applications. So why are we here today? What's kind of the summarized point of what our webinar is? Serverless applications have really started to grow in popularity over the last couple of years, kind of initiated by the launch of AWS Lambda back in 2014. And what we've seen as this space has grown is the sophistication and the needs of our customers have grown in terms of how they think about building and deploying their applications. And so in today's webinar, we're going to go a little bit deeper into what types of models and capabilities there are for you to deploy your applications, and help you understand a little bit of kind of the best practices that exist in this space. First things first, just want to kind of clear the table here on what it is that we consider serverless to be at AWS. For us, it really means four things. And really when we're here, we're talking about kind of the services and products that exist in this space. The first is no servers to provision or manage. This means no virtual, no physical, no containers even. There should be nothing that you as a customer of these products need to do from the perspective of managing the resources that are below these services. The second is that they should scale with usage. So as requests come in, the backend or the products themselves will automatically scale, handle these requests, and do whatever it is that the request is meant to be done. So effectively execute your business logic. Going along with this is a concept of never having to pay for idle. So there should be no need for capacity planning, which means there should be no need for you to have to think about over-provisioning resources and essentially paying for resources that you're not using at any point in time. So these services, again, will scale with usage, and you'll never have to think about paying for idle as part of that. And then lastly, availability fault tolerance are built in. For us here at AWS, availability and fault tolerance typically comes down to how you think about things such as availability zones inside of a region. For the products that we're going to talk about here today, you never need to think about the availability zones inside of a region. This is something that is taken care of for you with these services. At the core of our serverless world is AWS Lambda. So AWS Lambda is a compute service, and we call this a functions as a service compute service. And Lambda itself is actually also an event-driven service. So when we talk about a serverless application, it's made up of typically three components. We have an event source, we have our Lambda function, which contains the application code that you write, and then you have what it is that function does on the back end or in response to an invocation, whether that be talking to a database or another API or some sort of other backend service, or just completing the business logic that exists inside of your code. Happy to say that as of last week, we now support 5 different languages inside of Lambda. We have Node.js, Python, Java, C#, and most recently Go that was just added last week. So you write your code in one of these 5 languages and send it up to the Lambda service, and then your code is executed again in response to an event. And this event can be things such as changes in data state, requests to endpoints, changes in resource state, and there's today a couple dozen different services that can directly invoke Lambda on your behalf. Now, inside of Lambda, across the various services that can invoke it, there are effectively 3 different Lambda execution models: synchronous, asynchronous, and stream-based. Now, why this is important is as we talk a little bit later here in this webinar about the different deployment models that we have, thinking about how your execution model could potentially impact how you're thinking about deployment is really key. And so it's important to have a good understanding of what your invocation model is for a function. And again, as we talk through some of the concerns and thoughts that you'll have around your deployment model later, how these two things align. So in the synchronous execution model, as we have example here with API Gateway, I'm going to get a request to an API Gateway endpoint. It is then going to go and invoke a Lambda function, which I'm going to expect a Lambda function to respond back to through my API Gateway and back to my client. So that is a synchronous action. In the asynchronous events, what I have are messages or objects that might be sent to a service, such as a message posted to an SNS topic or an object uploaded to S3, which is then going to cause an invocation to a Lambda function. Now, in this case, I'm not expecting a response back to those services on the execution of this Lambda function. And so in this case, it's an asynchronous event. And then lastly, with stream-based events, which today we support for DynamoDB and for Kinesis, Lambda is actually going to be polling those services, looking for new information on those streams, pulling down records, I should say, and then doing whatever the business logic is that you have on those records. So again, 3 different execution models, some nuances to how you think about them, and then how you think about deploying as part of that. Now, one main component of the serverless application stack that we have here at AWS is Amazon API Gateway. API Gateway is a fully managed service that has just a ton of different features and capabilities for helping you to build very robust, very scalable, secure APIs. Today, you can interface with API Gateway either via CloudFront in what we call edge endpoints. You can also interface with it inside of a region for what we call regional endpoints. And then API Gateway can be backed by a number of different technologies. You can have your API running on Lambda. You can have it running on EC2. You can have it running on basically any HTTP or HTTPS endpoint that you might have. Say, for example, something that's running off of AWS. The other thing that you can do with API Gateway is you can actually put it directly in front of some services. So you can actually put API Gateway, let's say, in front of things like Kinesis or SNS or SQS and directly consume messages through it. By exposing the API as one that you control yourself. And so we'll also be talking here today about how you think about deploying your applications to API Gateway, as it is one of the kind of key use cases and partners in the serverless world. And so in talking about execution models and talking about some of these related services, basically what we see with Lambda is effectively kind of 6 common use cases for serverless applications. The first is web applications. So this is where you have some sort of web front end that's going to then talk to an API backend. And that API backend could be, or in this case is, hosted by something like Lambda and API Gateway. We then have actual application backends, so things like microservices that might exist as kind of components of a larger application. So again, microservices that exist as part of a larger application, mobile backends, IoT backends, where the client or the device is just directly interfacing with this API without, say, something like a web interface in front of it. Data processing, which is actually one of the biggest use cases by consumption today. This is things like real-time data processing, stream processing, batch processing. There's a number of workloads that exist inside of this space, and this is where we see kind of a lot of kind of really interesting things going on today. Chatbots. So today, Amazon Lex, which is a chatbot technology that you can interface with things like Facebook and Slack, has what's called fulfillment of the chat messages, the chat conversations by Lambda. And this actually ties directly into the next use case, which is Amazon Alexa. So if any of you have a Alexa-capable device somewhere, and you ask Alexa a question or ask it to do something as part of an application, a lot of times those actions are actually executed by a Lambda function. And if you ever want to go and explore and build your own Amazon Alexa function, or skill, I should say, it's actually a pretty fun experience. It's really easy to do with Lambda. And then lastly, IT automation. And this is probably where we see customers typically dipping their feet for the first time, is using Lambda as part of potentially like a glue type of service in reaction to other events inside of your AWS infrastructure, such as in relation to AWS config rules events, to CloudWatch events, to CloudTrail log information being processed as custom resources for CloudFormation. Again, there's a number of different use cases inside of just the AWS platform that you can use Lambda for. And so this is another thing to be thinking about alongside of the execution model is kind of what is the use case that you have? What is the invocation or the execution model for that use case? And then how would deploying to that service potentially impact its usability, availability, and so forth? And so as we talk through, again, some of the deployment considerations that we have here today, these will be some of the kind of key factors that we try to evaluate. Let's talk a little bit about serverless deployment patterns. Now, again, serverless technologies, while they change many things about how you build your application, they don't necessarily change everything. And so it's important to know kind of, again, what it is that changes, what it is that doesn't. But I just want to preface this by saying that for the most part, the terms that we're going to talk about are probably familiar to many of you already, and again, made possible by some of the new feature releases that have come out in the last couple months. So how are we going to talk about getting our new version of our code in place of our old version of our code? Or in this case, new versions of a configuration in place of old. And so today I'll talk about version new, version old. I don't want to get into semantic versioning or anything else like that that can sometimes border on a heated conversation. In this case, we're just going to take two versions, new and old, and talk about how we're going to replace one with the other. Now, there are a couple of different pattern considerations that we want to take into account. Obviously, we want our deploy to be successful. What does a successful deploy mean? Ideally, we'd like to minimize any impact to the consumers of our product. Again, given the various different use cases that we have, this could be an actual human end consumer, it could be a device, it could be another service, it could be someone talking to, again, Amazon Alexa skill. And so we want to minimize the impact to whatever it is that's talking to our service. We want to think about how we could deal with a failure of a deployment. And I actually call this out as the second most important aspect that we have to our deploy. At Amazon, rolling back after any sort of issue related to a deployment is typically the first step that you take. And so we'll talk here about how you think about rolling back from a bad deployment and how that might impact, again, the deployment strategy that you pick. Execution model factors. So we talked about 3 different types of execution models. We talked about 6 different types of use cases. How do you factor that into this consideration of which model you'll choose, which we'll talk about here in a second. And then lastly, deployment speed. Now, some people might say, well, I always want deployments to be fast and happen immediately. But there is something to the idea of a slower deployment, or potentially a more cautious or spaced out deployment. And so we'll be talking here about that as well. So we're talking about essentially 3 different patterns that exist that we kind of recognize as kind of being overall kind of like buckets of deployment ideology. The first is the all at once. This is basically where we are going to completely replace our old version with our new version. All traffic will go to that new version as soon as we basically click the deploy button. The second is blue-green. And now in the industry today, there are a number of different ways that people talk about blue-green. For us here at AWS, when we talk about blue-green, what we're typically talking about is the idea that we will deploy our version new into the same environment as version old. In a sense of EC2 or in a container world, this would be kind of a parallel infrastructure, you can think of it, for this one application tier. We will then take some testing or some tests, throw it at that new version, which we'll call the green version. And after we have passed through our synthetic tests, then we will then direct the traffic over to it from the blue version, which is essentially the old version. So again, in this case, we've got, for a small period of time, parallel deployments of our application. We've got the old, which is blue. We have the new, which is green. After some verification time period, then we'll swap the traffic over. And then lastly, canaries, or what we'll call linear deployments. This is very similar to blue-green, but in this case, what we're going to do is we're going to, in the case of a canary, deploy our new version, shift a small percentage of traffic to it. This is production traffic. And then after some amount of time of traffic going to this and us feeling that we have validated that this version is good and it's safe and it's not causing errors, then we would go and direct all the traffic to it. That's the canary model. In the linear model, what we're going to do is very similar. We're going to direct a small bit of traffic first, but then we're going to automatically increment the amount of traffic that we send up until 100%. And in this case, as more and more traffic comes in, then we might decide, based on increase in failure rates or suddenly seeing problems, to roll it back or not. So 3 different patterns again, all at once, blue-green, and then canaries or linear. So if we take some of the considerations that I mentioned before, and we take the 3 different patterns that we have, we can actually matrix them out here and start to think about some of the, again, concerns that we have and how they would help us in determining which one of the deployment models we should think about. So you can see here on this chart, I'm not going to go through maybe necessarily all of this here, but it's pretty straightforward. There's aspects to all at once that we want to think about from a consumer impact standpoint, where basically all of your consumers are going to be impacted. In blue-green, you are potentially relying on your testing to be thorough enough that you are not impacting your customers. And then for canaries and linear, you have the ability to potentially only impact a small percentage of your customers, and then again, increase that either completely or just in small increments. And again, so as part of this, you'll want to think about how that matters. From rollback, you see the all at once here is pretty straightforward. You have to cut back to an older version. In blue, green, and canaries are linear, you're going to revert back as well based on the fact that the other version is still there. For the event model factors, what comes into this often is basically the concurrency rate. And then if the workload that you have could support the idea of different types of execution against the same data source. And so for you, this is going to come down to a bit to how much you trust your testing, and then how idempotent the requests are that come into your service. As an example of this, if we were processing a Kinesis stream, we might only get one chance at processing some of those records. And so we want to think about how it is that we potentially experiment with changing the application while we're processing those records, with the idea that if we process them in a bad way, but it's still considered successful, you may not get any chance to reprocess those. And the last thing we talk here about deployment speed, again, coming back to the idea that you may not always want deployments to be fast. So an all-at-once deployment is immediate. That's going to take shape and go out there right away. But for blue-green and for canaries and linear, we could actually have a very extended period of time. It is not uncommon to see canary deploys where the canary percentage could persist for many hours before you actually then flip over to a full amount of traffic. For blue-green, you might want to sit that application there and bombard it with testing of various sorts before you flip traffic over as well. And so all of these are going to come down again to your direct use case, the amount of traffic that you get, to the related services, to what it is that you're processing. But these are some of the kind of basics that you'll want to take into account. So let's talk a little bit about how we can achieve these various models and what the tooling is that we're going to need as part of our serverless application stack. So the first one we'll talk about here is AWS SAM. And so SAM has this awesome squirrel mascot of ours, which you'll probably see on some of our landing pages, in many of our other talks, in many of our t-shirts and things that we hand out at events. Hopefully you can come and join us at a serverless conference sometime soon and get your hands on some SAM stickers. What SAM actually stands for, though, is Serverless Application Models. And so back in November of 2016, we launched SAM, which today is an extension on top of CloudFormation that greatly simplifies the work that's involved in building and deploying a serverless application. Really what it does is it helps simplify the provisioning and management of the underlying services on the AWS side. This is an example of a SAM template. SAM templates have a number of different components to them. The first that we see here are essentially the headers for CloudFormation. We see a template format version, and then we see a transform. In this case, the transform is kind of the key aspect of a SAM template. What it does is it tells CloudFormation that it should take this snippet of code and it should expand it into a traditional CloudFormation template. Then we have two different resources. First is a AWS serverless function, and the second is an AWS serverless simple table. In this case, the simple table is just a very basic DynamoDB table with a base amount of read and write units. But the serverless function, I think, is a little bit more interesting. And if we look at this, what we see are some properties that relate directly to a Lambda function, such as where the code lives, the handler, the runtime, the policy that I want this Lambda function to have assigned to itself. And then we see events. In this case, the event has a name of getHTML as a type of API, and then we see some properties that are aligned with an API level integration with Lambda. And so what this little snippet of code here actually does is it would go and it would deploy a Lambda function configured as defined here. It would also create for me an API gateway stage and an API endpoint that maps directly to my Lambda function, taking care of all of the permissioning that I need inside of my Lambda function, as well as the permissioning that I need from my API gateway to be able to call and execute my Lambda function. So this does quite a lot for me. Another way to think about it, to visualize this a little bit, is that this is an example that we have from a code repository of ours that you can go find up on github.com called the AWS Serverless SAM Farm. And inside of the SAM template file that we have here for this, what we see here is that roughly lines 9 through 25 actually generate for us 7 different resources inside of CloudFormation. And so if you were to think about doing this yourself using just raw CloudFormation resource definitions, it would actually be roughly 70 or 80 lines of code as opposed to being approximately 15 lines of code, give or take. So again, SAM greatly simplifies what is necessary for deploying serverless applications. This is definitely a place where you want to think about starting out if you're new in this space, as it's going to just really make it much, much easier for you to configure all of the related services. Let's talk a little bit deeper about these SAM templates and the properties that exist for them. So we see here a little bit more of what's possible to define inside of a serverless function. Again, we've already kind of covered the handler, the runtime, a description, memory size, timeouts, policies, key pairs for environments, the event mapping, the ability to enable things like X-ray via the tracing directive, as well as tags that would get applied to the Lambda function as part of this. And so again, you could potentially go and configure almost all the aspects about a Lambda function through a SAM template. However, it has a number of sane defaults that are set such that you don't have to go and specify them each time. When we go down to the events block, you actually have a number of different events that are built in directly into SAM. So today we have support for events from S3, from SNS, stream-based events from Kinesis or DynamoDB, API gateway-based events, CloudWatch scheduled events, CloudWatch events, IoT rules, and Alexa skills. And again, what this is going to do is it's going to help set up the identity access and management permissions for you such that you don't have to kind of get in there and configure those yourself. And so again, it really simplifies what's necessary for you to build and deploy your serverless applications. And now SAM is built on top of CloudFormation. And so as part of that, there are actually two commands that are part of the CloudFormation service today that are specific to SAM. The first is the package command, which actually, when run inside of your code repository, will create a zip file, upload that up to S3 for you into a bucket that's defined, and will then return back a code URI that you would pass to the SAM template on execution. The second is the deploy command, and this actually calls two different APIs behind the scenes. The first is the create change set API, and what this will do is take your SAM template and inside the CloudFormation service, expand this out into a full CloudFormation template, and then an execute change set. And then what this will do is actually execute what it is inside of the CloudFormation template on behalf of your user against those underlying services. Essentially, this is the thing that executes the actions of the changes that you've made to your template. So basically, package and deploy, having a SAM template inside of your code repository. This is all that you need to get started in deploying serverless applications today. One of the things that we launched last summer that goes along with this is a tool called SAM Local. Now, SAM Local allows you to build and test your serverless applications locally on your laptop or a development workstation, what have you. And so what this actually does is it uses Docker, and it uses a open source image that exists out there that mimics the Lambda runtime environments and allows you to locally either create a API proxy or be able to generate fake invocation messages against your Lambda function such that you can locally debug, test, and build your Lambda function's functionality without you having to deploy it directly to AWS. And it does this by looking at the SAM template and then setting up these related services alongside of it. So let's move a little bit here on from kind of the basics of SAM and talk about how we would use it to really deploy our applications. So if we thought about a API-based application where we had multiple different environments, today Lambda supports a concept of versioning and then aliases. In this case, versions are idempotent versions of your application. Basically, once they are deployed and defined, they can no longer be updated or modified. They can only be deleted. And then you have aliases, which get mapped to these versions. In this case, for my Lambda function that is called my Lambda function, I have 8 deployed versions of it. I then have mapped to it 3 different aliases, prod, beta, and dev. I also then have an API gateway, which has a number of different stages. And inside of this, I would pass a stage variable, which would allow me to map back to the Lambda function that I care about for this given stage, such that you see here, my API gateway stage for prod maps back to my prod alias, beta maps back to beta, and dev maps back to dev. And so as I go now to deploy my code, it would remap potentially an alias to a new version. So this is directly from the Lambda documentation. By default, an alias points to a single Lambda function version. When the alias is updated to point to a different function version, incoming request traffic in turn instantly points to the updated version. So again, as we remap an alias, that is effectively the same as an all-at-once traffic shift over to that new version that the alias is mapped to. And so what this means is that you could be exposing the end consumer of this Lambda function to any instability or issues that you have with that Lambda function. So again, this is a flip of a light switch, and everything is going to go to that newly mapped version. And so in order to minimize this, back at the end of 2017, we launched something called traffic shifting using aliases. Now, what traffic shifting allows you to do is it allows you to basically direct a certain percentage of traffic to a new version of your code via an alias. In this case, you don't have to do anything with the invocation side of the service. It will just automatically shift the percentage of traffic over to this other weight. So if we go back to our example here with our API gateway, if I wanted to promote what was previously my beta environment to prod, I could use the update alias command against version 6 and shift just 5% of my traffic to it. When requests now come to my API gateway endpoint, and then API gateway goes to invoke my Lambda function, on the Lambda invocation side, we'll handle directing the appropriate amount of traffic to this new version. And so you can think of this again in supporting of Canary or linear deployments. And then eventually, if things turned out good and I'm happy with my deployment, I can then go ahead and completely crank up the traffic to my new version of my application again, version 6, just by removing the routing config, or I could potentially set the traffic ratio all the way to 100. In this case, you're just going to remove the routing config and allow all the traffic to go to it. Now, there's a couple different ways that you can automate this. Back in November, we had a blog post talking about how you could use step functions to help with this. And we have an awesome kind of example here from one of the Lambda developers, Ryan Green, that walks through using step functions and a pretty awesome kind of execution flow here to understand if your Canary is healthy and if it's properly been accepting traffic and then allowing it to deploy out. But setting up and doing this with step functions is maybe a little bit of extra work, but you do have that capability. The other option that we have is something that we also launched at reInvent, which is something that we call safe deployments. So I had shown some examples previously of what a SAM template looks like. What this actually does is extend on top of it with a couple of different capabilities. The first is that we launched a section that can exist in your SAM template called globals. Much like the name sounds, it allows you to declare essentially global attributes that will define across all of the rest of the resources that are defined inside of your template. So for the example here of a function, we can specify the runtime once in the globals and then never need to define it in the individual resources. And basically any attribute that exists for a serverless function, we could define in the globals and have it be standardized across. And the other section that you'll see here is the deployment preference. In this case, deployment preference will help us in aiding the safe deployment capabilities that exist now via traffic shifting. So let's talk a little bit more about what it is that deployment preferences do. So there's two aspects to the template that I just showed there. One in the globals was a line called auto publish alias. What this does is say that every time that this function is deployed, it is automatically going to map the alias that's named to it to the version of that code that's deployed. So if I have auto publish alias prod, every time that this function deploys, it will always go ahead and give it the alias of prod. Then what I have in my deployment preferences is to define the preference for the deployment. So we see here is a couple of pre-built-in examples. For example, we see here Canary 10% 30 minutes, and it does exactly what it sounds like. It will direct 10% of traffic to the new version of my function, to the new alias mapping of my function, I should say, for 30 minutes. And then if those 30 minutes there isn't any sort of alarm trigger, it will direct all of the traffic to that. Similarly, Canary 10% 15 minutes will do the same thing, but for only 15 minutes of time, and then direct all the traffic. And then we see here an example of linear. So we'll take linear 10% every 10 minutes. What that's going to do, much like it sounds, is every 10 minutes increase the amount of requests that are going to my Lambda function by 10%. And you can kind of do the math here that after 100 minutes, it will be completely deployed. So you get to define what the deployment preference type is. You get to define what the alias is that you're caring about. And again, the alias is what you will have your invocating service be mapped against. Another aspect to this is a capability for alarms and hooks. And so alarms, pretty straightforward. What it allows you to do is specify today up to 10 alarms that the service will watch for in order to see if your deployment is successful or not. And so you could have, we'll talk a little bit more about this here today, alarms on things like latency for an API gateway. You could have alarms based on error rates. You could have alarms based on some sort of custom business logic. Basically, this is up to you to define what it is that would make a deployment be unsuccessful. If any of these alarms are breached, it will actually cause the deploy to halt, and it will roll it back to the original state. In the case of doing things like linear traffic shifting, it will shift all the traffic back to the original version. The same thing goes for Canary. And so this can really help you in automating that rollback process and making it directly related off of information that you'd be gathering from CloudWatch. Now, in the hooks section, this allows you to do a number of different things, and you see how it relates here to the life cycle of a deployment. In this case, we have a pre-traffic and a post-traffic hook. The pre-traffic hook gets executed after the code has been deployed to the new version, but before the alias has been mapped to accept traffic to it. And so you could use this to do testing of your function, to do testing of your function, to do any sort of potentially kind of pre-warming of information inside of it, whatever it is, it's up to you there. Post-traffic will execute after the traffic shift has happened, and this will basically allow you to, again, execute kind of whatever it is that you might need to do. Maybe you want to send a message to a chat tool or an email tool to say that the deployment has started. Maybe you want to update a configuration management database, anything that could be possible that you want to do as part of the lifecycle of your deploys. Now, all of this is actually made possible by capabilities that exist inside of AWS CodeDeploy. So AWS CodeDeploy is a service that's been around here in AWS for a couple of years now. Previously, it has allowed you to deploy code to EC2 instances or on-prem compute instances based on an agent that you would install. But as of our user conference reInvent back at the end of November, beginning of December 2017, it also now supports the ability for Lambda deployments. And so CodeDeploy supports the safe deployment capabilities that we see here in SAM. It allows you to do Lambda traffic shifting, enabling you to do things like Canaries and linear deployments, as well as essentially blue or green deployments. It has kind of some nice features again around CloudWatch metrics and alarms for rollback, and the pre and post traffic triggers could be integrated to call Lambda functions or even send messages off to SNS. A couple other cool things that come with CodeDeploy. So today, CodeDeploy actually gives you the ability to have completely custom configurations. So SAM today has pre-built ones that are integrated into it, but with CodeDeploy, you can actually configure these inside of the service such that you could do a Canary that has 5% of traffic shift for up to 1 hour, or do linear 20% every 1 hour. So you're not restricted to the predefined deployment configurations that SAM supports. You can do kind of whatever you want inside of CodeDeploy. You have also notifications that can be sent via SNS on a couple of different aspects of the deploy. So we saw before the pre-traffic and post-traffic hooks that existed. In this case, CodeDeploy also supports a number of different lifecycle events, which you could kick off an SNS message or a Lambda function to do all sorts of different things. And then lastly, it is a service that has a very rich console inside of the AWS console. And so you can have very easy visualizations of your deployments, of the status of them, if there were any rollbacks. And so it makes life just a little bit easier when it comes to thinking about how to deploy things. And so again, you can leverage the capabilities built into SAM to automate this process, or you could essentially configure and do your own inside of CodeDeploy. It's completely up to you. Now, another thing that I'll talk about here that also came out at the same time as these other capabilities is Canaries inside of API Gateway. So inside of API Gateway today, as part of a deployment, you can configure a stage Canary. What this does is, just like with Lambda traffic shifting, allows you to have the ability to shift a certain percentage of traffic to a new version of a deployment. And then you can, over time, choose to increase that or potentially remove it in the case of an issue, or again, completely ramp it up to 100%. Today, there is not any integration with SAM or CodeDeploy for this, so you would have to potentially think about building something into your pipeline, or your deployment pipeline, I mean, or potentially using something like step functions to help with the automation of this. But essentially, it works the same way in directing traffic to endpoints based on the percentage without you having to do anything inside of your clients. So as an example of this, if I have API clients, think of them as maybe a mobile application or web-based application, what have you. I currently have version 1 of my API gateway stage configuration, and that is then backed by whatever the backing service might be in this case, whether it be backends on AWS or backends that are running on other infrastructure elsewhere. As I go to make my deployment here, maybe I want to split this 50-50 and direct 50% of my traffic to one and 50% of my traffic to the other. I could definitely do that. And then or I could do things like do 10% to version 2 and 90% to version 1. Again, just like we saw with the Lambda traffic shifting. Again, with no need for me to change anything in my clients. This doesn't involve me needing to push out any new changes to DNS, any new changes to my mobile application. All of this is completely handled by the API Gateway service itself. And then eventually, once I've confirmed that things are good with my API, I can flip the switch and direct all my traffic to my new version. So there's a number of actually, I think, really interesting use cases with this. And some of them are different than the use cases that you would see for Lambda's Canary capabilities or Lambda traffic shifting with aliases. One is that, because this applies across the entirety of your API, it allows you to actually explore new capabilities or new thoughts in how you build your API. So whether you're using new languages, new frameworks, maybe you want to try Lambda in place of other HTTP endpoints. These are all things that you could potentially do as part of the same API. For example, we just had the Lambda Go release happen last week. You could very easily take one of your API backends that were written in another language, write one in Go on Lambda, put it behind the same API gateway, and be able to very easily test that out with a Canary, so only directing a certain percentage of traffic to it. With Canaries, you get the ability to compare and contrast performance with individual logs and metrics, which we'll talk about here a little bit further here in a moment. So you do get to see exactly what it is that's happening, what the difference might be if one is performing better or worse than the other. Another interesting capability this could allow you to do is to migrate an API. So we also announced the ability at AWS reInvent for you to have what are called private endpoint integrations inside of a VPC. This allows you to have a API endpoint that exists entirely inside of a VPC or one that is privately accessible, so one that does not have a public IP address. This works by leveraging network load balancers, which can then be mapped again to any resource inside of your VPC, or potentially even resources that exist on-prem or off of AWS's environment via a direct connect or VPN tunnel. And so you could use this as part of a migration strategy to move APIs from, say, your data center that you have today to an AWS environment by shifting the backend between different resources and using Canaries to test it out slowly over time, and then eventually shifting more and more traffic to it. And this can be done on a method by method or even action by action level. You don't have to do an all at once move as part of this. And again, that's kind of one of the best benefits of Canary-based deployments. So when we talk about kind of where you want to think about how Lambda-based Canaries and API gateway-based Canaries, when you would use one versus when you would use the other. So with Lambda, you're really only looking at a Canary on an individual function. So it's a single function granularity. Whereas with API Gateway, you're doing the Canary across an entire deployment. Now you can make just a single deployment for an API Gateway, or just say a single minimal kind of change to it, but it is going to apply to all of the traffic that goes to that gateway. In this case, both of these are transparent to either the client or the invoking service. In terms of rollbacks, with Lambda, you just roll back by setting the weight to 0. With API Gateway, you roll back by setting it to 0 or just deleting the Canary deployment. And then with Lambda, today again, we have automated tooling that's supported with SAM and CodeDeploy to automatically increase the amount of traffic that's going to the new version. Whereas today in API Gateway, we don't yet have any automation built in for this, but it's pretty easy to wire together again via actions inside of a code pipeline or via something like step functions. Now, lastly, what's common across both of these is that in both Lambda traffic shifting with aliases and API Gateway Canary support, is that both of them support the idea that a new version has unique logs and metrics that are created as part of it. What this means basically is that you don't have to do any sort of deep spelunking into logs or metrics to pull out the unique data. We're going to automatically do it for you. And so this can help make your understanding of whether your deployment has been successful or not much, much easier. So let's talk a little bit about how to think about using logs and metric data as part of your deployment. So we have a saying that we like to say with serverless applications, it's that metrics and logging are a universal right. What that means basically is that the products that we build for this platform have integrated in them right away from day one, basic logging and metrics collections that could then be extended upon by you as the user. So there's certain data that we are always just going to collect just based on the way the service is configured. And then we give you the ability to potentially generate other data as you need to. So when it comes to CloudWatch metrics, today there are 7 metrics that are built into CloudFront, including a new one around function concurrency. And for API Gateway, there are also 7 metrics today that we capture, things like 400s, 500s, latencies, etc. For CloudWatch logs for Lambda, we capture quite a bit just basically during Lambda execution, but anything that you do inside of your function that is the equivalent of, say, a console.log or a printf statement that would go out of your code will actually be captured by the underlying runtime and sent up to CloudWatch logs. So it's very easy to add logging to your functions as via CloudWatch logs. In API Gateway, we also have the ability to capture logs. We support a number of different formats. Via new custom formats, we support logging at 2 different levels, so we call it info or error logging. We also support the ability for you to capture full body and header requests, though you want to be cautious about turning that on for heavy workloads as it could potentially generate a whole lot of log information. And then one other aspect of CloudWatch logs that I think is maybe understated is the ability for you to do what are called log pivots. Now, what a log pivot does is it allows you to essentially set a regular expression against a log line such that you could pull out a key data point and convert that data point into a CloudWatch metric. So you can essentially use your CloudWatch metrics or CloudWatch logs to generate CloudWatch metrics and then generate alarms against those as well. So we see here a very basic example of a dashboard that could exist inside of CloudWatch. In this case, this CloudWatch dashboard represents a number of metrics that are captured across my different services, but it could also here represent a log pivot as generated again by the logs that I have. So one thing that I want to key on here is this alarm. As we see here, I have 0 errors inside of my alarm, and it's got a green checkbox, which means that the alarm hasn't tripped. But again, when we talk about deployment strategies and how you want to think about how alarms impact the deployment and potential for rollback, I think it's important to think about how it is that you configure this and what it would mean for you. So if we were to drill into this alarm that I have set here in my dashboard, what we would find is that, again, pretty straightforward CloudWatch alarm. What it basically says is if there are 5 errors for a single data point within 5 minutes, it's going to trip. So this is actually a pretty sensitive alarm. If it notices any number of failures from my function, it's going to assume that things are not good. And now if I was using this alarm as a alarm to be tracked by my SAM deployments or as part of CodeDeploy, again, if I had a bad deployment, it would cause those services to understand that there's an issue with my deployment and then force a rollback. Now we can actually configure this alarm inside of CloudFormation. And since SAM templates support basically any resource that CloudFormation supports, it's fairly trivial for me to go ahead and create alarms as part of my SAM template and then use these as defined inside of my SAM safe deployment definitions or as part of a CodeDeploy deployment configuration. So pretty easy to create alarms, pretty easy to generate data that you would use and then alarm on, pretty easy to get data into those services to do this as well. Again, you can take log data and create metrics. You can also create metrics just using the put metric API. And both Lambda and API Gateway provide a number of built-in pieces of data that you can use to create these alarms as well. So let's move forward here into talking about building the deployment pipeline. So far, we've talked about some of the tools that we use for deployment. We've talked about how you could use them to do percentage-based Canaries, both for Lambda and for your API gateway, as well as supporting the ability for you to deploy new versions using things like SAM and CloudFormation to support, for example, blue-green. What you're really going to want to do, though, is automate this process as much as you can. Here at Amazon and AWS, we basically have ingrained into our culture the idea that applications will only be deployed that have gone through some amount of continuous integration delivery process. Developers are not just going to push code out to a production environment unless it has gone through a pipeline. And so there are a number of different tools that exist out there. For us here at AWS, we have a product called AWS CodePipeline. And so CodePipeline is a continuous delivery service for fast and reliable application updates. Basically supports the ability for you to build and customize the pipeline that you need for your application. So any type of application that you could think of, you have the ability to define multiple what are called stages, which we'll talk about here in a moment, across a number of different actions, and get some assurance that your application is being built and then tested along the way. This here is a very basic example of a developer's pipeline. In this case, this pipeline has 3 different stages. It takes code from a code repository. It then builds that code using, in this case, CodeBuild, which is another one of the services in our Code Suite. And then in this case, it's using the CloudFormation actions for create change set and then execute change set to then go ahead and deploy my application using SAM. And then after this, it actually executes a Lambda function to run some testing against my Lambda function. And so anytime that I commit code, this pipeline will get executed. And so as a developer, I can have some assurance that my tests are being passed in and confirming that my application updates are good. Now we could expand upon this by adding on then the environments that we would need for staging and production. This example here builds off of my development pipeline by adding, as we see here, 2 more stages, one that I call staging, one that I call production. In this case, I'm continuing to show use of CloudFormation, as well as then other tests using, in this case, run scope. We also see here a manual approval. So CodePipeline supports the ability for you to have, say, another team or another process come in and require some sort of action to be taken to approve going forward through your pipeline. And then we see my production deploy. And so in this case, my production deploy, I'm also using CloudFormation and again have a Lambda function that I call after my deploy finishes. So just kind of a basic example showing here the type of flow that you'd want to think about. But let's go back again to our consideration matrix. So we've talked again here today about the tools, about some of the methodologies that you want to think about. How would you apply this then to a pipeline? How do you think about how your pipeline is potentially impacted by the different deployment models that we have aligned with, again, the tooling that we have? So in the all-at-once model, basically what we're going to look to do is we're relying on our pre-production stage, whatever you might call it, to be the place where we're going to validate that our code is good. Essentially because we're just going to flip the switch in production and direct all traffic to the new version, we don't have the ability to do in production any testing ahead of time. So we're going to have to rely on whatever a pre-production environment might look like in order for us to do this. If we look at the blue-green model, what shifts about this a little bit is that typically in a blue-green model, you deploy your green version or your new version into your production environment and then test against it against production resources. In this case, test the green version against, say, your production databases or other backing services. In this case, you've got a little bit more assurance if you have any concern about your environments being slightly off, that at least you're testing against the true production environment, and you should be experiencing in your tests the results that your consumers of the service would experience after you do the deploy. And then, of course, after you've validated, then you would direct your traffic over to this new green version away from the blue version. In the case of Canary or linear models, in this case, you're still obviously going to do some testing in your staging environment, but in this case, you are really kind of relying on production traffic against your production resources and the new version of your code to help you be able to understand whether or not your code is ready to go up for more traffic. And so for us here at Amazon, we very heavily leverage Canary-based deployments. We find that it's probably really the best way to know for sure that your application is ready and capable to handle the demands of production consumers of that service. And so this is a model that we internally favor quite heavily. So we've talked about a couple of different concepts here. Some of them are a little conflicting. You might have some knowledge or experience in some of the other capabilities of these products already here today. And so I want to kind of talk about a couple of just kind of general best practices. The first is use blue-green or canary-based deployments for production with a rollback as automated as possible. Really kind of the benefit of these deployment models is that it is fairly unimpactful to your end customers. And if you have the ability to do kind of really strong testing as part of it, then you don't have to put at risk all of your customers for what it is that you're doing. Now, Lambda supports a concept of versioning, and sometimes people think that when you use versioning over the long haul, that shifting aliases between them is necessarily just the only thing that you support, is the current alias. There are reasons for keeping versioning around. Another could be that you have to support multiple versions of your code, potentially to multiple consumers. In those cases, doing things like alias shifting may not work out well for you. In this case, you might have to just directly rely on those versions, keep either aliases or direct traffic to versions as static. And so blue-green or canaries may not be what you need to use. API gateway stages work pretty similarly to versioning. You're probably not going to want to use them as a way of directing traffic back to the same API endpoint over time, unless you do have to support multiple versions of your API. And in this case, again, where you have, say, different mobile clients that are pinned against different versions of the API. Otherwise, you probably do want to try to use canaries when possible. Lastly, this is kind of just a standardized kind of developer best practice, but try to use different environments for development, testing, staging, and production, or whatever you want to name these environments yourself. You really don't want to think about using stages or versioning for these different environments. You want to think about, again, stages or versioning to be used for supporting multiple versions in a production sense. Another potential option here is to think about using different accounts altogether. So pretty consistently, we see customers that have large environments where they will have completely different top-level AWS accounts that represent dev, staging, and production, as it were. So that's not a bad option as well. So kind of in closing here, as we've seen, a number of different capabilities across these products. Both Lambda and API Gateway today now support the ability for Canaries, which opens up the ability for you to do things such as blue-green deployments, or for you to be able to do Canary or linear-based deployments, increasing traffic as time goes and as you validate that the service is healthy. One of the key most important parts that I want people to come away with today is that automatic rollbacks should be considered kind of your first line of recovery for deployment-related issues. And you want to think, again, about what the impact is to the underlying service. But generally speaking, a safe rollback strategy is really key to doing deployments really well. Different event models and different workload sizes can cause you to choose different deployment patterns. Again, maybe if you have a CloudWatch scheduled Lambda function that executes every 5 minutes, you probably don't need a Canary deploy to be the model that you use for deploying that. That's probably an all-at-once deploy. However, if you have an API that's getting many tens or hundreds of requests per second, using a Canary deploy can help you not impact your customers all at once. You want to figure out pretty early on what the alarms are that you'd want to use to key in a rollback. Sometimes these could be alarms that are directly related to the AWS services that are part of your application stack. Again, things such as latency inside of an API gateway, errors that might be generated by Lambda. But you might also, again, want to look at how you can do your own metrics based on business logic. Again, whether you're using the put metric command or you're using log pivots, it's pretty straightforward for you to create an alarm off of a data point that is important to your business. SAM and CodeDeploy allow you to do a lot of this in an automated way without you having to build a lot of the glue capabilities. We're definitely looking at ways of helping to automate the API gateway aspects of this. Unfortunately, I can't talk about roadmap in today's webinar in the QA, but definitely understand that it's something that's very much key to us. In the case of SAM and CodeDeploy, again, though, number of different capabilities around traffic hooks, around how alarms are integrated, around how you could do Canary and linear-based deployments at certain percentages over periods of time. And so for Lambda-based applications, I think this is definitely probably the way to go when you're looking at your deployments. You can find out about this and pretty much everything else that I've talked about here today off of the main serverless landing page, aws at amazon.com/serverless. We've got a ton of information, getting started guides, links to our documentation, case studies, other webinars like this as well, so you can continue to learn more there. And my name is Chris Munz. I'm a Senior Developer Advocate for serverless here at AWS. You can find me at Chris Munz on Twitter or munz on amazon.com. If you have any questions or you need any help with anything, always happy to help people out. So do feel free to reach out.